In today's lesson, we're going to look at dividing polynomials. And before we divide polynomials, I want us to review long division of just regular numbers. So let's start with dividing 65 by 3. Remember that when you set up a long division problem, you're going to put whatever your denominator was on the outside and, oops, sorry. And whatever your numerator was on the inside. And then you'll go through your long division and ask yourself, okay, how many times does 3 go into 6? If it goes into 6, in this case it does, it goes in 2 times, so we would put a 2 up here. And then we multiply. So 3 times 2 is 6, and I subtract. And then we bring down the next value. And we start the process all over again, asking ourselves how many times 3 goes into 5. This only goes in 1 time. Now multiply 3 times 1 to get 3. We subtract. And this 2 that we get left over is our remainder. So we would write this as 21, remainder 2, or 21 2/3. So I wanted you to review long division of just regular numbers first, because this is going to be very similar, the process at least, to how we divide polynomials using long division. One little thing I like to use to help me remember the order for long division is, does McDonald's sell cheeseburgers? And this little phrase right here will help you remember the order in the process for dividing. We'll always start by dividing that term from the inside by the term on the outside. As we did here, we divided 6 by 3. And we got 2, so we put that up here. Once we got 2, so the D stands for divide and does McDonald's. So the M stands for, once we got that 2, we multiplied it by the 3 on the outside. So 2 times 3 gave us 6. Right? We did this. This was multiplication. So does McDonald's, the M stands for multiply. Once we multiply and get our number and write it down below, we subtract whatever we got from what's under the radicand, and then we check our work to make sure that we've done everything correctly, and that whatever we did get when we subtracted won't divide by, oops, went the wrong way, won't divide by this number outside. So then we lastly bring down, that's what the cheeseburgers, the B in burger stands for, the next value, and we start the process all over again. So does McDonald's sell cheeseburgers means divide, then multiply, subtract, check, and bring down the next term. If DMSCB helps you, then please, by all means, write it off to the side, DMSCB, and check it off as you're going through your process so you don't lose where you are in your long division. So today we're going to look at dividing polynomials. So I've got 10x squared minus 26x plus 3 divided by 5x minus 3. And so I have a trinomial actually divided by a binomial. To do this, we're going to need to use long division. You'll notice that all the terms do not share a common factor, where if they did, we could divide out a common factor and try to simplify it, but that still wouldn't allow us to fully divide the numerator by our denominator. So we will use long division. And the way we'll set this up is just as you would that 65 divided by 3, that was your warm-up, where you'll put whatever the numerator was inside and whatever your denominator was outside. So here I have the long division set up where my numerator, 10x squared minus 26x plus 3, is under the radicand, and my denominator goes outside. Okay. So we just went through a little phrase, does McDonald's sell cheeseburgers? That will help us keep track of the order in which to do this long division. And the first step is to divide. Well, looking here, we know we can't divide this entire polynomial by that entire polynomial. That's why we're using this process. So what we'll do is focus on the first term inside and divide it by the first term outside. We will always deal with the first term outside when we're dividing in the divide step. So you will ask yourself, how many times will the first term of the outside binomial go into it, I should say. So 10x squared divided by 5x. What does that leave us with? And we should get 2x as the simplified version there. So you could say, all right, 5x goes into 10x squared 2x times, or just think about 10x squared divided by 5x simplifies to 2x. So just as we would, once we do that division, we will put whatever we got there above the radicand and start building our answer. Now, I want you to notice that this is a 2x to the first. So when you're lining up where that 2x will go, you're going to look for the term that has an x to the first and put it above that. So this 2x actually will line up above the 26x when we do that. So that's our first step. Now I'm going to click to the next slide so we have space to carry on with the rest of the process. So we did the does, we did the divide, we did 10x squared divided by 5x, and we got 2x. The next step in long division is to multiply. Does McDonald's? M stands for multiply. When you do this, you are going to multiply your 2x by every term out here in this polynomial. So you will do 2x times 5x and 2x times negative 3. And again, when you do that multiplication, you will line up whatever you get under their like terms under the radicand. So 2x times 5x should give 10x squared, and 2x times negative 3 is negative 6. So notice I've put my minus 6 cleanly under the 26x, sorry, minus 6x, excuse me, so that they both are in the x to the first column. And this, we want to be the same. That is good if that happens. So that when we subtract, does McDonald's sell, our subtract step, those go away or become 0 when we subtract. So now you'll subtract negative 26x minus a negative 6, which is really plus 6x, giving you a negative 20x. Check and bring down is the final step. So you can see we bring down that plus 3. We have now gone through one full cycle of long division. However, we're not done because we now are left with, and you don't have to write this 0 by the way, but we are now left with negative 20x plus 3. We want to go all the way until we get either a remainder or everything goes away. So you need to ask yourself, can negative 20x divide by the first term on the outside, that 5x again? We will always, always in the divide step use the first term on the outside, the 5x. You ignore the 3 for the divide step. So does negative 20x divide by 5x? It does. So I could come off to the side if I need to and do that division. And we should be left with a negative 4x. And I've run out of room, but we get, sorry, not x, just minus 4. I'm sorry, the x's clearly cancel. I'm thinking faster than I'm talking. Okay, so negative 20x divided by 5x is just negative 4. And that negative 4 we will place above this plus 3 because those are both constants, numbers without variables. Once you get that to be your negative 4, we've now done divide again, and we're going to go through the multiply, subtract, and bring down process one more time. So now I take -4 and multiply it to each term outside. So -4 times 5x is -20x. That's what we want to get. -4 times -3 will be plus 12. Let me erase some of this so it's a little cleaner. Okay, again, you don't need to write this here. Okay, once we have done that multiply, which I think I have written down here, yes I have, then you will subtract what you got. So I'm subtracting these. I've just spaced it out so it matches up with my wording on the left. But you would naturally put it just right underneath as I had just shown you. So we have a -20x minus a -20x. So -20 minus the negative is really plus, so -20x plus 20x is 0. So these do subtract out to be 0, which is what we were looking for. And then we will do 3 minus 12 to get -9. At this point, you do want to check that -9 will or won't divide by 5x. Because there's no x here, we can't further continue this process. So we're going to be done, and this -9 is considered our remainder. Now, just like a remainder, you'll write your remainder over the original denominator and add that to your answer, and your answer is up here, your solution. So that means that the final divided out expression for this long division is going to be 2x minus 4, which comes from what we got up there, plus you'll add the remainder, -9 over 5x minus 3. 5x minus 3 is just the original denominator, so we keep that as the denominator. So just like when it was 21 and 2/3, I believe in the warm-up problem, 2 was the remainder, so we wrote it over 3, the original denominator. And so this boxed in piece is your final answer. Let's do another one together. And as you pick up on this process and this cycle, you will get more comfortable with this. So here's our next example, and I want you to notice that we are missing a couple terms here. So let's look at it. So it's 2x cubed minus 30x minus 8 divided by x squared plus 4x plus 1. Both of these polynomials that we're dividing are in descending order, which is great. However, that numerator is missing a term. It's missing the x squared term. If we were to count the exponents on the variables, we go from a 3 to a 1 to an x to the 0. It doesn't have to be written there. Remember, that's just 1. But we are missing a term in the middle here that has an x squared. So when you set up your long division for this, you are going to put a placeholder. Remember, numerator goes inside, denominator goes outside. You're going to put a placeholder for the term 0x squared. You'll see why in a moment. Okay, but if you notice that you are missing a term in the descending order, put a 0 with that variable and the exponent you're missing. So 0x squared I can add anywhere because it is just 0. So we're using it as what we call a placeholder. All right, let's start the process. We begin by dividing, and you always divide the first term inside by the first term outside. So 2x cubed divided by x squared is 2x. All right, so if it's 2x to the first power, I'm going to line that up, that answer that I get, above the term with x to the first power that's underneath the radicand. So 2x cubed divided by x squared is 2x, and I've lined it up above that -30x. So we've divided. Next, we multiply. 2x gets multiplied by every single term outside. So 2x times x squared will be 2x cubed. That will be written under this. 2x times 4x is 8x squared. And here is why we needed the placeholder. If I get 8x squared, I need a place for it to line up so that in the next step when I subtract, I have something to subtract it from. So that's where we're going to put the 8x squared underneath the 0x squared placeholder. And then the 2x times 1 is 2x. So we got the 2x cubed plus 8x squared plus 2x. We've got our placeholders so that I do have something to subtract 8x squared from. So divide, multiply, we now subtract each column. So 2x cubed minus 2x cubed is 0. 0x squared minus 8x squared will be negative 8x squared, and negative 30x minus 2x will be negative 32x. So I got my negative 8x, and I got my negative 32x. This is 0, so remember, you do not have to write that. I don't like to write extra things that kind of clutter up the space that we don't need. Okay, so we divided, we multiplied, we subtracted. Now we check that this will divide out, and it will, and we bring down that minus 8 that's hanging there. And we start the process all over. So I'm going to erase these markings. And we begin by dividing the first term here always by the first term outside. So negative 8x squared divided by x squared. The x's all cancel out, leaving us just with negative 8. Now that we've divided, we will multiply negative 8 by every term here on the outside. Please make sure you're multiplying a negative 8. All right, so negative 8 times x squared is negative 8x squared. Negative 8 times 4x is negative 32x, and negative 8 times 1 is negative 8. Divide, multiply, subtract is next. So now we subtract our like terms, and you'll find negative 8x squared minus negative 8x squared, those are 0. Negative 32x minus a negative 32x is really plus a 32x, so that means those are 0. And negative 8 minus a negative 8 is really negative 8 plus 8, which is 0 as well, meaning we have a remainder of 0, which is a really nice situation to have happen because that means your answer is just whatever you ended up with up top, 2x minus 8. So this one nice and cleanly divided out. And the thing to take away from this problem was that if your numerator was missing a term in that descending order, you do need the placeholder so that when you are going through the process, all your like terms can line up under something else. So this one divides to be 2x minus 8. Okay, there is an example that I would like for you to attempt on your own. Once you're done and ready to check it, you can click play after pausing the video to work it out. Okay, so with this problem, hopefully you put the 2x minus 1 outside and the 6x squared minus 7x plus 15 inside. You'll notice that your numerator is not missing an x to an exponent term in the descending order. It goes 2, 1, 0. The exponent on this one's a 1. Remember, technically, there can be an x to the 0 there. So we are good. We don't need a placeholder in this example. Okay. So when starting, 6x squared divided by 2x gave us 3x. Then we multiplied 3x to get 6x squared minus 3x. Then we subtracted all of those. Those become 0. And we're left with negative 4x, and we bring down the plus 15. Then we divide negative 4x by 2x to get negative 2. Now we multiply negative 2 by everything outside to get negative 4x plus 2. We subtract, and we're left with a remainder of 13, which means when you write your final answer, this is written kind of as like you would think about a mixed number like in the whole number position. And then you add the remainder on top of whatever the original denominator was. You just copy the 2x minus 1. Okay. We have another one for you to try. Again, first thing to look for is, are we missing a term in the descending order in the numerator? We have an x cubed, an x squared, an x to the first, and an x to the 0 on that 12. So we're not, so we should be good to go to set up the numerator inside, denominator outside. Pause the video, work it out. When you're ready to check, click play. Okay, so setting this up, you can see that, oh, some pieces are missing here. We have x cubed divided by x is x squared. We multiply it out to each term outside, getting x cubed plus 2x squared. Then we subtract. These become 0. And we're left with a negative 4x squared, and we bring down the minus 3x. You can bring down the plus 12 as well. Now I divide negative 4x squared by x to get negative 4x. And now I multiply negative 4x to each term outside, giving me the negative 4x squared minus 8x. I'll subtract these, leaving me with a 5x. Negative 3x minus negative 8x is positive 5x, bring down the plus 12. And still we divide first term here by first term here. On the outside, 5x divided by x is just 5. It's positive. Now multiply 5 by everything outside to get 5x plus 10. And we subtract to get 12 minus 10 is 2, which is our remainder, because the 2 will not divide by the x on the outside. So when you're writing your remainder, again, just recopy whatever the original denominator was, and whatever you got up here, that is your answer. Or the whole number portion of your answer, I should say. The whole thing's your answer boxed in. Okay, we have one more, and I do want you to take a close look at that numerator. We are missing an x squared term. So when you set this one up, you will need a placeholder there. So use a 0x squared in between the x cubed and the x to the first term. Work this one out. When you're ready to check it, after pausing it, click play. Okay, so for this one, it should divide out cleanly. And here is that placeholder that I was referring to, that you will need a 0x squared, because our exponents went from 3 to 1, and we were missing the term in the middle of those that would have an x squared. And we need it so that when we get this 28x squared, we can subtract it from something here. Okay. Dividing polynomials often just takes a lot of practice to get in the habit of the divide, multiply, subtract, check and bring down process. Once you get that habit down, and then always looking first term inside divided by first term outside, this process hopefully should get more comfortable for you. So that's the end of our lesson, and we'll practice more of this in class.